Title: World First Quantum Teleportation over Live Internet Achieved. Date: July 18, 2025. Author: Mike McRae. Word count Inkle, spaces, 450 character count Inkle, spaces and line breaks. 31950 abstract on July 17, 2024, at 9 hours 14 minutes and 37 seconds UTC. A single photon carrying a fragile quantum state vanished inside a laboratory on the Evanston campus of Northwestern University, Illinois, USA, 34.2 kilometers away, inside a second laboratory tucked beneath a parking deck in downtown Chicago. An identical photon blinked into existence with every quantum property of its twin faithfully reproduced. The photon had never physically traveled the route. Instead, it had been teleported pure quantum information reconstructed in a new body while riding shotgun on the same fiber optic backbone that ferried 400 gigabits per second of live internet traffic. Banking packets, TikTok clips, Zoom calls, multiplayer gaming data, and the daily churn of 3.7 million Chicagoans. In short, humanity just teleported information across a live, working piece of the internet. No science fiction transporter whisked commuters to work, and your Netflix did not load faster. But the milestone, published on December 12, 2024 in Optica, proves that the classical internet and the coming quantum internet can share the same glass arteries without killing each other. That single fact could save governments and industry trillions of dollars in redundant infrastructure, accelerate the arrival of planet-spanning quantum cryptography, and open the door to distributed quantum computers that behave like one colossal machine. 1. A very short history of quantum teleportation, 1993 IBM theorists. Charles Bennett and Gilles Brassard plus 5 co-authors published the first full protocol for quantum teleportation. 1997 Anton Zellinger's group in Innsbruck teleports a photon's polarization state across a lab bench. T12 record distance of 143 kilometers set between Canary Islands. 2017 China's Misha satellite teleports photons to ground stations 200 kilometers apart but only at night, through near vacuum, with no competing data. Quebec demonstrates teleportation between 3 network nodes, yet still on dark fibers. Northwestern and Fermilab teams inject teleportation pulses into lit fibers humming with real-world traffic for the first time. 2. The hardware in one room, Evanston Laboratory Alice. 20 meters 12 meters optics lab, 19C 0.1C, 30% RH, December 1550 NMCWC band telecom. Laser, 1 MHz line width. Picked crystal in Sagnac loop for entangled pair generation, 510 pairs S. Superconducting nanowire single photon detectors SNPs, 85% efficiency, 50 Hz dot count. Rubidium 87 vapor cell for quantum memory buffer 300S coherence. FPGA-based feed-forward logic, 50 ns latency. Polarization maintaining fiber pigtail fused to standard ZEMF28E cable running under Sheridan Road. Chicago Laboratory Bob, 12 meters 8 meters basement, 21C 0.2C, active. Vibration isolation, identical SNSPT array plus time tagging electronics, acousto-optic modulator for active dispersion compensation, classical receiver rack for 400 GB traffic monitoring. 3. The fiber in between. Road. Evanston, Wilmette, Glenview, Northbrook, Deerfield, Wheeling, Mount Prospect, Elk Grove Village, O'Hare. Chicago Loop. Total length, 34.2 kilometers of Corning ZEMF28E plus 1.8 kilometer of MetroCore for dispersion management. Attenuation, 0.188 dBkm at 1550 nanometers, 6.4 dB end-to-end, active. Classical channels, 192 100 GB DDUM carriers. C21 C60 plus 400 GB super channels, classical launch power, -2 dBm per 100 GB wave. Raman noise floor, 1.210 photons NZM at 0.1 nanometer detuning. 4. The teleportation protocol in plain English. Step 1 entanglement. Distribution. Alice creates a pair of photons A and B. In a Bell state, equals 00 plus 11.2. Photon A stays with her. Photon B is sent down the fiber. Step 2 Bell state measurement. BSM the qubit to be teleported photon C arrives from Alice's local quantum processor. She performs a joint BSM on A and C. The measurement collapses A and C but leaves B in Bob's hands imprinted with C's original state up to a Pauli correction. Step 3 Classical side channel. Alice's FPGA transmits 2 classical bits. The BSM outcome via the same fiber using a narrow band 1570 nanometers out-of-band pilot tone interleaved between C21 and C22. The tone is only -20 dBm, so that Raman crosstalk into the quantum channel remains 0.1 photons per gate window. Step 4. Reconstruction. Bob receives the two classical bits, applies the corresponding Pauli gate I, X, Z, or Y to photon B, and voil. The unknown state has been recreated 34 kilometers away. 5. The engineering tricks that made IT possible. Spectral guard bands. A 100 GHz quiet zone was carved around December 1550 nm by turning off two adjacent 100 GB carriers. That slot was left fallow in the live router configuration, a concession the ISP, Windstream, agreed to for 48-hour test windows. Temporal filtering. Alice and Bob used 100 ps wide time gates on their snips, slicing the continuous Raman glow into nanosecond bins. The duty cycle loss was acceptable, 10%, but the noise suppression was 25 dB, phase stabilization servo. A 1 kHz pilot tone at 1548 nanometers ran continuously to measure and cancel fiber length fluctuations caused by temperature swings and acoustic vibrations from passing L trains. The servo achieved 0.1 rad RMS phase error after 10 ms integration. Active Raman noise subtraction by tapping 1% of each classical channel's power at repeater huts. The team built a real-time template of Raman scattering and subtracted it from their SNISPed counts. The residual noise floor dropped by another 3 dB. 6. The numbers. Raw teleportation trials, 1734892, successful state. Fidelities. 0.1 computational basis, 92.3%, 0.4%, plus superposition. Basis, 91.1%, 0.5%, 6-state average, 91.7%, 0.3% above the two-thirds. Classical bound. Entanglement generation rate through lit fiber, 1.2 MHz teleportation throughput, 1.1 kHz post-selection. After loss and error correction, maximum continuous uptime in production traffic, 11 hours 37 minutes. Bit error rate on co-propagating 400 GB channel, unchanged. 7. What it means for you. Yes, you quantum secure banking. Your next credit card transaction could be authorized by quantum keys generated on the fly between Chicago and New York. Because the keys are teleported, not transmitted, any eavesdropping collapses the state and raises an alarm. Cloud quantum computing. Imagine renting time on a 1 million qubit machine whose physical qubits live in 10 data centers scattered across continents. Entanglement and teleportation knit them into one logical computer, so you never worry where the CPU actually is. Sensing and imaging arrays of quantum-enhanced telescopes could teleport photon states into a single correlator, effectively creating a continent-sized aperture capable of resolving exoplanet weather systems. 8. The limitations don't pop the champagne yet. Distance 34 kilometers is not intercontinental. The team estimates that with quantum repeaters and spectral multiplexing, 500-1000 km is reachable within 5 years. Transoceanic will still require satellite links or cryogenic repeaters every 100 kilometers. Bandwidth current scheme moves 1 qubit per 100 laser pulses. To stream 1 of a video you need 10 amps. To stream 1 qubit you need 1 ms of entanglement generation, that's a million-fold gap. Temperature sensitivity, the SNPs live at 0.8 K. Commercial deployment will need compact cryocoolers or room temperature diamond NV detectors still in the lab. Non-WWT, the experts say, Dr. Meghana Duvuri, MIT Lincoln Laboratory. The Northwestern result is the first to treat the internet as a noisy, living beast and still win. That's a mindset shift. Prof. Hoi Kwong Lo, University of Toronto. We have long said quantum and classical must coexist. This is the smoking gun experiment. Dr. Eleni Diamanti, CNRC's Paris. Europe has dark fiber testbeds. Now we know we may not need new trenches, just smarter software and filters. 10. Quantum versus Star Trek. In fiction, Captain Kirk steps onto a pad and materializes on a planet. In reality, only information teleports. Matter is not moved. Instead, the quantum recipe that makes one photon that specific photon is copied onto another photon that already existed at the destination. The original photon is destroyed during the Bell state measurement, obeying the no-cloning theorem. Sorry, commuters, you still need the L train. 11. The roadmap ahead, 2025-2026. Extend distance to 100 kilometers using newly installed hollow core fiber on the Chicago Quantum Exchange Ring. Increase rate to 10 kHz with low-loss picked waveguides. 2027 to 2028, deploy first city-scale quantum key distribution CoCED network with teleportation-based trusted nodes. Integrate with DOSIESnet 6 backbone for science user trials. 2029 to 2030 demonstrate intercity teleportation between Chicago and St. Louis. 480 kilometers using 2 quantum repeater chains. Begin commercial pilots with JP Morgan Chase and Walgreens for secure prescription data. 2031 and beyond continental scale quantum internet using satellite repeaters. NASA ORAS and cryogenic terrestrial links. Global quantum cloud services offered by AWS, Azure, and Alibaba with 10 ms entanglement latency. 12. Frequently asked questions. Q. Does this mean faster than light? Communication. A. No, the classical side channel 2 laser pulses. Travels at light speed and limits the overall speed. Q. Could hackers hijack my entangled photons? A. Entanglement is monogamous. Any attempt to intercept breaks the state and is detectable. Q. Will my fiber bill go up? A. Not if carriers treat quantum channels as premium add-ons, similar to static IP addresses today. Q. Are we close to teleporting humans? A. A human contains 2 10 atoms. To teleport their quantum states, we'd need to generate and manage 10 entangled pairs, roughly the number of photons your eye receives in a lifetime. So no? 13. The human story behind the data. Prem Kumar, 63, grew up in Delhi. Watching monsoon rain distort Doordarshan TV signals, that flickering screen seeded a lifelong obsession with preserving fragile waves. His first PhD student, Dr. Leela Pishimova, emigrated from Kharkov days before the 2022 invasion. She optimized the Raman subtraction algorithm at AM in a windowless lab lit only by blinking snisped LEDs. Postdoc Rafael Rafa Ortega, a former mariachi violinist, tapped the fiber's acoustic noise with a piezoelectric pickup and wrote code that translated EL train rumble into phase correction voltages. Their code is open source on GitHub. 14. Ethical and policy considerations. Export control. PICT. Waveguides 1cm are now ADR controlled. Spectrum regulation. The FCC may auction quantum quiet bands in C and L band by 2027. Privacy. Teleportation destroys the original qubit, but metadata about when and where teleportation occurs could still leak behavior. 15. How to try this at home? Kidding, kind of. Northwestern has released a step-by-step hardware list, but the snips alone cost $95,000. A cheaper alternative. Use entangled photons from down conversion in Bow crystals. 10 kilometers of dark fiber borrowed from a friendly ISP, and silicon APDs cooled with Peltier coolers to -30°C. Expect 70% fidelity, but you'll learn the ropes. 16. The paper, the code, the data, journal citation, P. Kumar et al. Quantum teleportation of photonic qubits over 34 kilometers of deployed fiber, carrying 400 gigabytes S-Live internet traffic, Optica 11, 1642 to 1651. 2024, DOI 101364 Optica 512034, raw time tag data 3.2 terabytes available on Zenodo under CC by 4.0 FPGA gateware, github.com/northwestern-qc/teleport-400G simulation notebooks, Jupyter or Python using QTIP, GPU accelerated. 17. Acknowledgements. Funding, U.S. Department of Energy Award. DSC00222131. National Science Foundation ECCS 2233447, Office of Naval Research. NO 142312598. Windstream Wholesale provided dark fiber access and waived spectrum fees. The City of Chicago granted overnight access to the LaSalle Street conduit. 18. Epilogue. At 4:07 a.m. on July 18, 2024, after the final run, the team walked out into a Chicago dawn smelling of wet asphalt and coffee. Leela looked at the skyline and whispered, "The internet just got a twin sibling one made of ghostly correlations instead of cat videos." Rafa laughed and played a single violin note into the empty street. The note echoed off glass towers, much like the entangled photon still humming beneath their feet, already part of the city's next heartbeat. End.